Here's a problem that's similar to the last one. This one also includes friction on the horizontal surface. In this case, we're trying to, again, find the final velocity, and we're going to define our system. You can define it as broadly or as narrowly as you want. I'm going to define it broadly, so it's the block, spring, earth system. We have that the change in energy, right, which let's define point 1 as the point where the block is released from rest, and point 2 being at the top. Right, so the change in energy is equal to E2 minus E1, and that's equal to the external work on the system. Right, so that's our work energy theorem. And in this case, because there is friction involved, the external work is the work done by friction. And so we can't define our system to include everything because friction is always an external work. All right, so now we need to get expressions for each of these, and then we can set up our equation that we would solve for the velocity. So I've got at E1, well, we can go ahead and just include everything possible. And so we might have kinetic energy, we might have potential energy from a spring, and we might have potential energy due to gravity. Right, the kinetic energy is 0 because we start from rest. Again, we'll define our potential energy due to gravity equals 0 at the lowest point. So we've got no potential energy due to gravity there. So we just have the spring potential energy, which is 1/2 kx squared. And then at point 2, we've got, we could have kinetic energy, we could have potential energy from the spring, and we could have potential energy due to gravity. But in this case, the spring is no longer involved, so that goes away. So we're going to have kinetic energy, which is 1/2 mv squared, and we're going to have potential energy due to gravity, which is mgh. Finally, we have the work done by friction. We know that's always negative, so that's equal to the negative force of friction times the displacement. And the negative force of friction is going to be mu sub k times the normal force times the displacement. And in this case, because the surface is horizontal and there's no other vertical forces acting, we know that the normal force balances out the force of gravity. So in this case, Fn is going to be equal to mg, because it balances out the force of gravity. So the work done by friction is equal to negative mu sub k times mg times the displacement. All right, so we can take E1, E2, and the work done by friction and put them into our equation that came from the work energy theorem. So E2 is 1/2 mv squared plus mgh. E1 is the potential energy due to the spring, so we subtract that. And then the work done by friction is equal to negative mu sub k mgd. All right, so now this equation can be solved for the velocity. So all that's remaining is algebra. So I'll go ahead and show that. All right, so at this point, all that remains is to plug in numbers. Now, we can think about what we would expect here. And if we got a situation where we were trying to take the square root of a negative number, that's not allowed in physics. You can't have an imaginary velocity. So what that means is that the block wouldn't have enough energy to make it all the way up the ramp.